Hi guys, we're gonna get started now. So I'm down. So welcome to workshop 3 of Data Science at GT Bootcamp. I hope all of you guys are doing well and are not too under the weather with all the rain. This workshop is going to be.
I don't know if the voice is catching it though.
It should be.
Should be? I just don't see the. Well,
We can see it.
It's fine. All right. So the topic of this week's workshop is going to be data preprocessing, which is actually a really important part of any sort of data science application that you want to work on. Yeah. These are the main 4 things we're going to cover today.
And just a reminder, milestone 2 was due today. Technically, we don't have like hard deadlines, but we want you to be on track. So please have your milestone documents uploaded as soon as possible to your Google Drive.
Also, quick PSA: if you're here and your mentor has like scheduled a meeting with you, but you haven't shown up, please show up to your mentor meetings. It's very important. And we are taking attendance.
Anyone have any questions before we start? Cool. So I'm going to skip these steps because we've already done this like the past 2 workshops. Essentially, if you want to have access to this file, get the file, make a shortcut to your drive, make a copy of the file, and add it to your names folder in participants. And I already did this, so I'm just going to run this code. So first thing we're going to do is make some imports. So we're going to be using pandas and NumPy. And NumPy is a library used to manipulate data. One buzzword you'll definitely hear in data science is machine learning. If you search up what is machine learning, you'll probably see like 1,000 different definitions. But the definition is pretty simple. You essentially have some data, and you model that data to try and understand it, and then use that data to make predictions about the future data. And you can see the pipeline here to be more specific. There's 2 types of machine learning, or 2 main types. There's unsupervised and supervised learning. So in unsupervised learning, we're essentially given a bunch of data, and we don't have any output data, and we essentially try to understand information about the data. So we can use many methods for unsupervised learning, like clustering, dimensionality reduction, and kernel density estimation. I would highly recommend you take a machine learning class because you'll go over each of these in that class. So CS 4641 goes over all of these. And then supervised learning, it's pretty different from unsupervised. You're given a bunch of data, and you're also given the data's output. So like whatever the data is supposed to predict, you're given that output, and you try to use that relationship to make new predictions. So there's a couple of different models to do this. We have tree-based models where you have like a decision tree. So at each node, you have to decide whether to go left or right, and you keep going until you reach a leaf node, which tells you what decision to make. There's also linear regression, which I think most of you guys have heard of before. You're essentially fitting a lot of data to a line, find the best fit, and then use that to make new predictions about the data. And a very advanced topic is neural networks, which will be covered in workshop 5. Neural networks are essentially like a layer of inputs with a bunch of weights in the hidden layers, and you use that to make outputs. And you use a loss function to determine the best weights for the neural network. Like I said, we'll go over that more. We'll go over more over that in workshop 5. This is pretty advanced, so I highly recommend you attend that workshop. And 3 main ways to describe ML models. So we can do it pictorially, decision boundaries, or mathematically. So the first way is pictorially. I guess I can ask you guys, which picture corresponds to which algorithm? Which one is a neural network? Second one. Which one is a decision tree? First one. And the last one is a support vector machine, which is another topic you cover in ML. Essentially, a support vector machine, I think most of you guys probably haven't heard of this, but you're essentially making the best line And it's similar to linear regression, but your line can be non-linear as well. So instead of this line, you could have like a zigzag line. So something like this. It's a more advanced version of linear regression, essentially.
Yeah, support vector machines, a little more on that, is you're using it to classify data into different groups. So just to give you a little bit of like an overview, the support vector machine, the way the line, or rather the decision boundary is made, it's basically one dimension less than the feature space. So if you have a feature space of 2 dimensions, your support vector machine is using 1 dimension to have a decision boundary. And what you want to do, in the example here, there are multiple ways of separating data. You could have like the line in the at the example right there, like you said, you could also have like a zigzag line, or you could have lines at different angles. But but the trick is, how do you choose the optimal divider? And that is through a maximum marginal classifier, which is basically you take the closest point from one side and the closest point of the other, and you basically get the perpendicular distance, or you find the midpoint, and that will basically position or angle the line such that it will clearly support the data. And that only happens when the data is linearly separable, which is a term that you can use for data which you can clearly find like 2 groups or 3 groups or some things like that. So I don't want to go too much into it, but that is essentially what this is. Support vector machines are mostly used for classifying data into different clusters. That's all.
Yep. So classifying, by the way, is like what kind of category does it belong to, and regression is like what numerical value does this data point take on. Another way like we can do it is decision boundaries. So similar to a support vector machine, you try to find the best lines that split classification groups. So in this case, like a linear line would work. In this case, you can't just make one line, you have to make multiple lines. In this case, it would probably not be good to use linear regression, you have to use some sort of non-linear regression. And some other algorithms you might see are KNN, K nearest neighbors, and like we mentioned, support vector machine. You can also use a neural network to help you in classifying data, and also in regression. So another way to represent is mathematical formulations. So with data, all you're given is an input, and you want the data to output a certain value. So all you really have is like a mathematical formulation that maps X to Y. And that's what all of these models are really doing. So for example, if we're given this data of an image, we try to convert this image of pixels into essentially like a classification of what this image is. You can see like we split this image into pixels, and then we try to extract features from it and determine that it's a jellyfish. And if you take computer vision, you'll learn more about how certain features are extracted. And finally, we can use like something similar to linear regression. So I think you've all seen y equals mx plus b. That's the equation of a line. Does anyone know what this line underneath is representing? The y equals theta 1 x1 plus theta 2 x2 plus theta 3 x3. That's not quite what I'm looking for. So notice here we have one input x. What is this representing?
Multiple?
Yeah, we have 3 inputs.
Linear regression.
Yeah, it's linear regression with multiple data points. And we have different weights associated with each of those weights. So it's just more advanced linear regression. And then this line, I'm pretty sure you guys know it's a polynomial of cubic or third degree. And the goal of ML is essentially to optimize the values of these weights. So what's the value of MB, B, theta 1, theta 2, theta 3, and it depends on which model you're making.
Okay, so a little more, just to clarify, if you guys have taken linear algebra, the theta 1 x1, theta 2 x2 is called, it's a term called like a linear combination, which is essentially for each dimension, like x1, x2, x3, you have a coefficient, which will basically determine how the variable behaves throughout a feature space. So the linear combination of that, it determines a line or a plane or whatever, and how it's going to fit with the data points. So the weights that you're trying to optimize will give you a linear combination in that feature space.
Moving on to classification versus regression. We kind of touched on this, so I guess you guys can describe the examples. So if I want to determine whether an email is spam, is that classification or regression?
Classification.
Yeah, so why is it classification?
Trying to figure out what a thing is.
Yeah, so it's essentially like a yes or no answer. If I want to predict the price of a house, is that classification or regression? Regression. Why is it regression?
Quantity and so.
Yeah, it's a quantity, so it's like a continuous value. It might take in like 100,000 or 200,000 or 200,000.50. It can be like a range of values. And moving on, I guess, if you want to classify this animal or toy, it's a bear. If you want to like rate how high, I guess this is how hot it is or something, 9.5 to 10. That's a regression problem. So
you could also have problems where you can use both techniques. A classic example is for example, like a classic example is probably a stock predictor, or rather, like with predicting whether a stock is viable or sellable, and you would think that it's a classification problem. You could also have it be a regression problem where the stock difference that you're predicting, like the profit or the loss that you're predicting, that's a continuous value that you're trying to get. And you can also convert it into a classification problem where if it's positive, it's bullish or you can buy it. If it's negative, that means stock is going down and it's bearish, or financial term here. You should probably sell it. So it doesn't have to be either regression or classification. You can have a problem to both. So just keep that in mind.
yeah, so to actually do these like ML models, you need to have a good data set, and you also need your data set to be pre-processed. So if you ever like get a data set from Kaggle or any other website, it's pretty rare that you'll find it to be like completely good to use straight away. There could be flaws in the data itself. So if you're missing values, or the values are poorly formatted or not in the form you want, or there might be data that's like not useful at all or redundant, which we want to get rid of. So it's very important to pre-process your data before you try to make ML models. Otherwise, you might have like repeated features or missing values, which will cause your code to crash. So how do we address this?
Does anyone have any questions about like any of the AI like models that we went over?
Cool. Yeah. So how do we address this? So there's a couple of ways to handle missing values. Something called value imputation. That essentially just means that what's a way to convert like missing values into, how do we convert missing values into useful data? So we can either replace the data with something else, or replace it with an average, or something, even other options. So to do that, we're going to show some examples. So first we're going to read in our data set, which is the same one we've been using. So I'm going to run this code, but this should be a review. What does this code do?
Subset of this.
Yeah, so this is going to return a subset of the columns, specifically passenger ID, age, and fare. If I run this, you can see we just get those three columns. So this is some code that's kind of advanced. You don't really need to know how this works, but essentially we're generating like NA values in this data set, because if you look at this data set, there's not really that many NA values, but this code is just going to make that like a lot more. and specifically like 20% more. And if you're interested, I would definitely recommend looking at the documentation of how you do this. But if you look at our data set before, you can see we only have like one NaN value at row 88 to 88. But if you look below, we're generating a lot of NaN values. So notice in row 2, we generated one here, row 4 here, and row 887 here. There's also some more like between 5 and 885, but we just don't see them. So now that we have missing values in our data set, we're going to try to clean that data up. And there's going to be a couple of ways to do this. First, actually, let's visualize how many there are. So this is null, just represents a false or true of where the values are null. And this function here to print out the number of null values along the column axis. So that's what this axis equals 0 does. If I replace this with axis equals 1, do you guys know what that would do?
Do it for the rows.
Yeah, do it for the rows. And if you do this, it's not really as interesting as if you do it for the columns because you're just going to get zeros, ones, or twos. So let's go replace this back. Yeah, so we have 181 missing values for passenger ID, 319 for age, and 178 for fare. So there's a couple ways to address this. One way we can do is just replace all missing values with a different value, so like all zeros. Another way we can do it is replace the missing values with a numerical value, like the mean, the median, mode, etc. And then a more advanced way to do it is called backfilling. So essentially with backfilling, you fill the data with the prior existing value. And we're going to see examples of this. So with fixed value imputation, this code here essentially looks at the passenger ID column, looks at the NA values, and fills them with this thing, this value that you put here. So if I run this code, you can see that if we look at passenger ID, all of our NA values just became N. And we can replace this with like 0. Oh.
Bit of a lag there.
I think that's actually why this doesn't work. Because, so does anyone know what in place equals true means?
Doesn't it basically modify the table like without creating a new copy in there?
Yeah, so we're modifying the table directly. So once we've already modified the values, these aren't NA anymore. If I wanted to fill it with zeros, I have to run the original df constructor. So once I remake it and then fill it with zeros, now you see, I have to remask it to fill it with an A, and now fill it with zeros. So you see we're replacing with zeros. So that's one way you can do it, replace it with a single value. Normally this isn't the best way to do it. A better way, in my opinion, especially for values where like there's a meaning to the numerical value, you can fill it with the column's mean value. So the way you do that is use the .fill_NA method again, but instead of using like a single value, use the column's mean value. So to get the mean value, just do mini df of your column dot mean. And I don't think we'll be able to see, I guess we can see what that actually looks like. So notice in row 888, we have an NaN. If we look here, see in row 88, we have the value replaced with 29.634038, which doesn't really mean much in terms of age. So if you wanted to, you could like floor this value or take the ceiling of it to get like a numerical number. That actually makes sense. And then the final way we're going to look at is backfill. So like I mentioned, backfill looks at the prior existing value that's valid and not NA, and it fills the value with the missing value with that previous value. I don't think there's any examples with fare because we don't have any NA in rows 0 through 4 or 886 to 890, but it did modify the values because if I print out yeah, you can see we have no missing values. Another way you can do this is something called forward fill. If you want to do it backwards, so you replace it with the next value that's open, you can also do it that way.
Another trick also. So do you see how when you have the dot sum, like before you would have axis equal to 0, which would get the sum of a particular column, like the sum of NAs. Here he didn't put it at all, and now it actually make the same result because the axis is defaulted to 0. So if you wanted to get the sum of, or like get a column, or organize it by column, or do something with it, like sum or mean or things like that, so you don't have to put axis equal to 0. If you wanted to get the row part though, then you would have to put axis equal to 1. Just put out a trick here.
Yep. So I guess the question to you guys is, in what cases would you use each approach? So like in what case would you just fill it with, 0 or the mean value, or use something like backfill or forward fill? Any ideas?
How about for passenger ID? If you have a missing value in passenger ID, do you think it would make more sense to just replace it all with zeros, or take the average passenger ID, or to backfill it?
And remember, with backfill, you can take the previous value and also add it with a constant if you want to do that. So which one would make sense most there? Backfill, yeah. You do a backfill and then add +1. Because notice that would line it up properly. And I guess for age, which one should you do? Yeah. It would be the best here. Maybe floor it or take the ceiling of it just to make sure it's a actual integer.
Although in some cases you do have to use your own judgment. For example, it could be that the reason why their ages are missing is because say that they're underage, they don't need to report their age, in which case you can probably just put a fixed value in, to say, oh, you're all 5 years old, you're under 5. People under the age of 5 just don't need to fill out their age or something.
Yeah, you really should try to understand why there's missing values, because if you do replace it with the mean, and like Nicholas mentioned, if they're missing because the ages are less than a certain value, then you probably should not replace it with the mean because they're under a certain age. And yeah, to discuss more about feature creation and manipulation, Abhijat will be doing that.
Hi guys. So all right. So let's get into the feature creation. So there are two ways in which you can sort of manipulate or create features, or just edit the data. The first way to do it is you can edit with rows. So essentially, so here I'm just getting what this does. It just gets the first 5 rows or so of the data set of the data table basically. Now, all right. So I guess I'll ask this: Who remembers what zero indexing is?
Zero indexing on this.
Yeah, basically, you're basically indexing the row, right? So, for example, if you wanted to return a row, of index 2, then it will basically what you will see is all this stuff from row 2, which corresponds to this. So yeah, that's basically what it is. The .ilog is basically what that function does is that it returns the row. So yeah. Now, what if you wanted to get a particular value at a particular row? Sort of like when you have a 2D array, but instead you're not using just indices. You're also using the row index and the column feature. So in this example, you're getting the value from row 2 and from the age column. So that'll essentially just return 26, which corresponds to this. So pretty simple stuff. It's just trying to access the data table. Now, if you wanted to assign or to edit certain values, you can basically do like just an assignment operator. So let's say you wanted to, you want to update the age at this exact row. You can basically use this assignment operator and multiply it by 1.25, and then the output was essentially be 32.5. And if you wanted to just get that's my bad. If you wanted to get like the whole row, so here, I multiplied it like twice. That's pretty cool, actually. So, so basically, what I did is, not only was I was trying to output the value at row index, like row 2 and at the age column, and I was also trying to upload the whole row, and just outputting it twice, it will basically multiply it twice. So that's basically that's basically what you can do when editing rows. This next part, which is actually a major part of like feature engineering, is editing columns, and that is where the feature creation comes in. So when you're creating a column, you're basically creating a feature, but also note that when you're creating a feature from the table, you're basically deriving that feature from the current features that you have. That can be done through like mathematical functions, or like if you wanted to add like another feature in like separately. But however you have it, you are editing the data frame, and therefore you're doing feature engineering that way. So this is how you create the column. Here you're just using a constant value. Like this is the name of the new column. You could also use a random value, and then you could also manipulate old columns. So here, here you're basically incrementing 1 to every value in the fair column. So instead of, if I go back here, in the fair, instead of having these values, you'll just get 1 more from those. So, so let me go back down and there you go. So this is what I'm talking about here. So here before it was 7.25, now it's 8.25. Here it was 71, now it's 72, so on and so forth. So that's how you create a column. Now the feature creation with the where syntax. Now the where is, if you have worked with like SQL or like different queries, you might sort of you might think that it will sort of work the same way, and you probably be right. Basically, the where function is a condition, and in the parameter, you're basically putting, okay, you want to output values that are less than 8.0. In this case, like here, you're trying to get a data frame with the values where the fair is less than 8. Else it will be 0. So if I output this, so it is affordable. Huh?
It's all the way on the right.
Yeah, I don't know how to. Oh my goodness.
Go down this one.
Yeah. Okay, there we go. So this is what you get as a result. So you're so basically what I did, sorry if I explained it wrong. So you create a column called is affordable, just like you do like with creating a column. Then you use the where, and if the fair is less than 8, that 1 will stay there. If it's not, it will change that 1 to a 0. So the is affordable is because this is less than 8. It's not a for loop because this is greater than 8, and so on. So those are just one of like many things you can do to engineer features. I have like my own example from like a project that I'm doing for like research. So maybe I'll show it to you afterwards, but like in the sake of time, I'll probably show it after. But yeah, so here, what you're doing is you're creating like a mini data frame. So if I play this, so this just outputs a data frame using the rows where the age is equal to 22. So yeah. So as you can see, each and every one of these rows has an age of 22. So what you're doing is you have your original data frame, and it's just another way of using where, except now you're just using that original data frame as a parameter, or the condition as a parameter, and you're getting a mini data frame out of it. That's basically it. And the deriving features. So this is where the mathematical functions come in. So let's say that you wanted to, get an age-weighted fair. Basically, you're using the age as the weight and the fair as the original value, and you want to multiply the two together. So here you're creating a new column. You're assigning it each value in this row to a value of said age times fair. So what that will do is it will get the value from the age, it will get the value from the fair, and it will multiply it to get this result. And it will do the same thing to all the rows that you have that are in the data frame. So that's the mathematical function I'm talking about. Another example I'll just show in here. That's a little bit of my research. I'll just show it real quick. Is you have oh, this works? Okay, thank you. So basically, one of my projects is clustering friction resistance and tip resistance of things when you're trying to push something down. So when you get the different measurements, you have a friction resistance, and then you have the tip. Now, if you have a problem in which you're trying to, for example, cluster different things, and you're just not able to, get a clear cluster of or a good enough, model out of it, then one way you can do it is to create features using mathematical derivations. One simple thing you could do is you can do a ratio. Oh, this is terrible. So then basically you can take, let's say the friction resistance is 20, and the tip resistance is 80. You can basically take the ratio of friction to tip, and you can get, and then that will be your new feature. So that's just another way of creating or deriving features from the features that you have to make it in the hope of making the data more separable or clear or more robust. So it's just a lot of experimentation to figure out how you're going to derive features, what mathematical functions are you going to use, or how you're going to edit the rows, how you're going to edit the columns, whether you need to create new columns or drop some columns, information that is not needed. So all of that is under the realm of feature engineering. And on that note, you have the non-useful data. So when I talked about, you want to drop specific columns that you're not using, or there are different data sets which are just not useful at all, then that might be something to think about, whether you want to include in your model or not. So So can anyone tell me, so, like different examples of having non-useful data? If you guys have any ideas. Anyone? That's okay. So basically, some examples of not like non-useful data is like with heart disease, right? So you have like there's some relevant pieces of data which include age, like weight, height, genetics, things like that. Some data that might not be useful is I don't know, weather or something like that. Like what is the weather in which you got diagnosed with heart disease? Like that is not useful data, and when you have like different columns or rows, or not, sorry, that's not what I meant to say. When you have so many columns of non-useful data, that's just cluttering your model. You want to be able to take those out, but oh, go ahead.
There was the access one.
Huh?
What is the access one?
Oh, we
I haven't gotten to that part.
yeah, we haven't gone to that part yet. Actually, if you can explain.
Yeah, so like axis equals 1, that just refers to column wise, and then x equals 0, that's row wise. So if you want to drop on a column, you have to do x equals 1. If you want to drop a row, you need to do x equals 0.
Yeah, so axis is 1, you're just dealing with the columns. Axis 0, you're dealing with the rows. That's basically what it is. So yeah, like going back to my point about like non-useful data, if you have data like weather or like how many friends do you have, like which school you went to, things like that, those are just not relevant to the heart disease model. At least like in a sense, like rationally speaking. So if you have multiple columns or multiple features which may include data that is just not relevant, you might think about like taking those this data out, because when you have extra information, you're basically increasing the computation. A fair warning though, you want to be careful what you're taking out, right? So like there, of course, like just make sure you cross-check things like that. But yeah, a way to like get rid of the non-useful data, you can drop the columns, you can drop the rows, like x equals 1. And basically, that just the result of it is just the data frame without these columns. So yeah, that's basically it. And now we'll get more into the feature manipulation with words versus numbers.
All right. Before I start, does anyone have any questions? Okay, cool. So when you think about it, like, what's a computer really good at? Computing, right? And computing is all about numbers. But people like to think about words. Like, we all have language and stuff, and numbers. Well, language is made up stuff, but like it's something our brains made up before we came up with math. Anyways, when you have input values into your whatever model you want to use, you want to make sure that your features are discrete and continuous, because that's what the computers are best at working with. They're not really good at working with like a categorical sort of input, because that's the sort of output you want, right? You want to take like a input variable and change it into like a category a lot of times. So for example, we're going to look at data frame, right? So we have name of the owner, the sex, and the cabin number. So here we're just looking for all the like unique sort of values to have for names for each of the columns, actually, right? So for names, you see there's like everyone has a different name, sexes, and these are all the cabins they have. So when you think about it, right? So how do you want to like assign each of these unique values into a number or value that the computer can work with easily? So the two main ways that people go about doing this is either matching each value to a feature, or to one-hot encode, or just like change to binary, basically. Like if you have like if your category only has two possible values, then that's very useful. Otherwise, you can just assign like a separate number to each of these, like 0, 1, 2, 3, 4, 5, blah, blah. So here's another data set that we're using. Yeah, it's just like, I'm pretty sure this is just, this data set is about like information of passengers on a Titanic, what number they are, whether or not they died, their age, blah, blah. So we're going to look at all the different values they have for embarked. There's an AND value, so if you want to work with that, it's probably best to like either drop it or use any of the feature manipulation things you talked about earlier to sort that out. Yeah, what we're doing here is just replacing it with Q. Not quite sure what the S, C, and Q mean, but it's not too important. Here we're using a dictionary in order to assign each of the unique values to another number, right? So S is going to be mapped to 1, C is going to be mapped to 2, Q is going to be mapped to 3. Yeah, we're going to replace it like that, and here's a new one. So as you can see, when it was an S before, now it's mapped to 1. It was a C before, now it gets mapped to 2. So now we're using cat codes. Basically, every single unique entry gets assigned a number. So we're doing this on class 20, going from 3131 to 2020. Yeah. Now, basically what this line of code is doing is that for each of the different like possible unique cabin places, it just gives you like, it just adds a column for each of them and like another Boolean, like 1 or 0 based on which class it's on. So yeah, see what? For a lot of cases, this is obviously not very good because we just increased the number of columns by a lot. So honestly, in like most circumstances I can think of, it's probably like better to just get rid of the cabin column in general, because like there's not too much important information that you can extract out of it. Now, drop all the missing values, data types. Yeah. Anyone have any questions about this bit? Okay. Yeah, now we're gonna look at how these sort of like data manipulation like tips can like help improve the performance of different modeling algorithms. So here, this example, we're just going to use a very simple like one variable linear regression. Feature extraction is basically using only the features that are most important to our model. Basically, you see all these like white columns, they're just like a column that that's not very important for the model we're trying to use, so it's like we're just dropping it from the data frame. And then, I don't know if you guys learned this in linear algebra. Basically, you take like a weighted sum. This is very easy if you just multiply two matrices together and get an output value. and you try to find the weights. So it's like the A transpose A inverse, blah blah.
All of that is basically done using NumPy. So if you want to take a look at the document, it's actually pretty easy to use. If you need any help, I can help you.
Yeah, I have to work with. And these are just all the columns. And just using your own judgment. Yeah, you're kind of like have to use like your judgment here in order to like make the model best as you can. But that's good because it's where you can pull ahead of the competition. So, right, let's just say you have a data set that has 1 million features. This is honestly really common in like a lot of like sort of industrial applications. You just have huge data sets. Like imagine you work for like Facebook or Google or like any really big tech company. You have like probably billions of different like data entries to like, you know, track what you're doing at every moment in time. So with your like 7-figure salary, how do you like make this shit actually be able to run? So what we're gonna do is this is making a new data frame, and it's basically just taking from this subset of the columns. If you remember, we had a separate column for each of the different cabins, which is like I mentioned earlier, not important. Yeah. At the end of the day, it's just up to you to like process data in the best way possible. And sometimes like you can use data to like smooth out irregularities or to correct any sort of errors you might get from a model after you do a processing too. Or like let's say you have one model that's really good at classifying things, and you want to feed that input into another model. So yeah, this is another example code that I wrote like a few years back. It was for a generative music project. Do you guys want to see it? Right. So basically, this is actually a post-processing algorithm, but what it did was you would just get a MIDI file, and every single note would get assigned a pitch, and then here, in order to like make the music sound better, it will only give you a melody, but this one would give you like a bass like to harmonize with it, and it would just assign like a key signature to every single bar, and yeah. So you can use like data processing basically at any sort of step of your machine learning model, whether it's like for putting into the model in order to make sure you get the result you expect, or to clean up sort of really wonky results that you might get from a model that might not like fit what you're looking for.
Does anyone have any questions? Okay, if not, you guys go ahead and sign in. Here's the QR code. And if you guys don't have any questions, you guys are free to head out. And we'll stick around for a few minutes.